Hi, everybody. Another question, AP Physics question, going back to some principles of Newton's laws. So let's take a look at it. This question's showing us a piston with a gas in it, a block on top. You might think, all right, okay, maybe I need to know ideal gas stuff. But when you read it, it's really just talking about Newton's third law, right? Every force has an equal and opposite force. So let's read it. A sample of gas confined in a cylinder with a piston that moves with negligible friction. There's a block on top of the piston, and the piston is at rest. Which of the following makes a Newton's third law force pair with the force that the block exerts on the piston? Okay, so I think one of the problems is sometimes people think anytime we have equal and opposite forces, those equal and opposite forces are um, they're a Newton's third law force pair. So let's see an equal and opposite example that a lot of people think of right away. So totally separate from this problem, you have a desk. You put a book on the desk. So here's my book. Now what do we have in this situation? The book's in equilibrium, is it not? There is a force of gravity down, Fg, right? That's the weight of the book. Now why isn't it accelerating down? Because there's an equal and opposite force up. This is the normal force. This is not a Newton's third law force pair. Okay. Yes, they're equal and opposite, but when Newton talks about that equal and opposite, he's talking about when something applies a force on something else. When A puts a force on B, B also puts the same force on A. So let's look at these. Okay. Let's find the force pair that goes with the weight. What is this? This is a force on the book, right? I'm going to say on the book. What's doing the force? What's applying that force? Think about it. Earth, right? Earth and the book. Right now, I'm going to draw. Here's my book. Here's Earth. Book is being pulled down. Guess what? Earth is being pulled up. Same amount. These are equal and opposite, right? If I push on the door pushes on me. That's a force pair, a Newton's third law force pair. Okay, well, let's try and find the opposite force here. So normal force, that's the force on the book, right? Since this is a free body diagram of my book, right? Both of these forces are acting on the book. What's doing it? On the book, by the desk. Okay, which means the book is also applying a force on the desk. So if I was to draw that force pair, here's my desk, right? The desk is being pushed down with the same force that the desk is pushing the book up. There's my Newton's third law force pair. So in this problem, they're asking us about that same type of force pair between the force that the block exerts on the piston. And that's going to be the force that the piston exerts on the block. All right? So I hope that helps clarify some things and reminds you a little bit about Newton's third law. Take care. Good luck on the test.